Hello dear students, so welcome all of you on this beautiful online learning platform. Myself Princey, your science teacher, and today we will discuss about the topic periodic table. So in the periodic table, we will first of all describe the elements. So what are the elements actually? Elements are the substance having same type of atoms. So the substance having similar type of atoms are present is called element. So in today's time there are 118 elements are present upon earth. So to classify these 118 elements on the basis of their similarities, their dissimilarities, and give them a proper way in a tabular form, the periodic table was arranged, and today we study the periodic table. So in the contribution of this periodic table, long form of periodic table, there are several scientists and their models was contributed. So this long form of periodic table was came into existence. So first of all we will discuss about the history of the periodic table. History of the periodic table. In the history of the periodic table, there are three prominent scientists who have contributed. First one was Dauvernier. Second one was Newland. And the third and most prominent name was the of Mendeleev. So we will discuss one by one. First of all, Dauvernier. So Dauvernier proposed a theory of law of triad, that was called law of triad. He actually said that if we take average of two elements, first and third, the second element will be find out by their atomic mass having similar properties. For example, if we take chlorine, bromine and iodine. If we take average of chlorine and iodine atomic masses, we will find out the atomic mass of bromine. So he proposed the law of triads actually. These three on the basis of three elements. So but this theory was actually discarded because we can't find the triads of all the elements. After that, Newland octave rule was came into existence. So this was called law of octaves. So Newland said that the elements are arranged on the basis of their increasing order of their atomic masses. The eighth element having the similar property to first one. So this was called law of octave, but this theory, this proposal was also discarded because this was only applicable up to atomic mass number 40, that is called calcium. After that, Mendeleev periodic table was came into existence. The best part of Mendeleev table was that he proposed his table on the basis of atomic number. So this is the best part of Mendeleev periodic table. He arranged the periodic table in a tabular form having 12 rows and 8 columns. And he proposed at that time 63 element was present. He arranged the element on the basis of their increasing order of their atomic number. But some demerits of Mendeleev was that there was no proper place for the hydrogen atom element, and there was no space for the isotopes of the elements, and also there is no space for the discovered elements. Like in nowadays, if you discover any element, you can't place in Mendeleev periodic table. So this periodic table was also discarded. After that, with the with the contribution of these three scientists and their periodic tables, long form of periodic table was came into existence, proposed by Moseley in 1970s. So this is the modern long form of periodic table we have to study today. In long form of periodic table, this was arranged in on the basis of atomic number. There were 18 rows here called groups, and 7 columns, you can say horizontal lines, these are called periods. There are groups 1, 2, 3, 4, 5, and at last there is called 18th group or called zero group, because here inert gases are present. Inert gases because they do not react with these elements generally. You can see here there are 4 blocks. Blocks are decided on the basis of electronic configuration of an element. So the last electron enters into substance, that is called block in the periodic table. So here is S block having 2 periods. Here is D block having 10 periods. Here is P block having 6 periods. And this is called F block having 10 periods. Okay. Actually, F block is in situated D blocks perpendicularly. So F block is situated D block perpendicular, but you can't show it in 2D arrangement. So this is situated at downside of the periodic table. Here you can say in the S block, D block and in the F block element, metals are present. In P block elements, there are non-metals and semi-metals, which are also called metalloids, are present. Metalloids are those having properties of both metals and non-metals. So here boron, silicon, astatine, tellurium are metalloids are present in P block. Okay. So this is the brief and basic form of long form of periodic table I have described here. You can say metals are mostly in solid form. So all metals are except mercury. So all metals are present here, and non-metals are in gaseous form or in solid form are in present here. So there are 11 gases which are present in periodic table. Mostly are present in P block. Okay, so here you can say that there are 7 periods present in this periodic table. First period is known as very short period having only 2 elements. Next one is called short period, and the next one is second and third period is called short period. Next fourth and fifth period is called long period having 18 elements, and the 6 and 7 period is called very long period having 32 elements. Actually, I have described the number of elements on the basis of formula called 2n square. Here n is the number of period, you can say. Okay, n is the number of period. So if you say period number 1, so number of electron will be 1. Period number 2, number of electron will be 8. The element also will be 8 here. So this is the brief basic form of periodic table I have described here. I hope you understood it very well. Thank you so much.